and welcome to Berkshire Guitar Amplifier Repairs. In the workshop today I've got a Marshall JVM210C. The C stands for combo, which this is. The customer says that he hasn't used it for quite a long time. It could actually even be a year or two. And when he last turned it on, which was obviously ages ago, it didn't work and there was no sound. And he wants me to get it going for him again. So unusually I'm not going to turn this amp on. I want to have a little look at it first to see what's going on. And so I think the first thing I'll do is take the back off, have a look, and maybe I'll bring it up slowly on the variac and see if I can see what's happening. But I'll take the back off, we'll have a look at the valves and inside and see what the overall general condition of the amp is. Well, that was certainly a good decision on my part. I just took the back grill off here and I think you can see immediately we are in big trouble with this amp. Anytime you see this kind of milky looking cloudy effect on a tube, it means that the tube has lost its vacuum. 3 tubes that have lost their vacuum, and hang on a minute, this one's actually broken, look. Completely shattered. The others maybe. What's this one like? Yep, that one's broken too, look. Completely cracked. What that means is that this amp has had a major trauma, and I suspect it's been dropped from a great height. Fun enough, I did think something like that when I turned it round, because the chassis seemed... Yes, can you see that movement of the chassis there? That is very loose. You can actually see these screws, look, wobbling. So my view is that this amp has been dropped. There's no obvious sign of it having been dropped. There's no crushed corners or broken parts. But dropped it has been. So I've emailed the customer to see if he can remember what actually happened to this amp, and that will tell us a little bit more. See, when an amp's been dropped from a height, you often get problems with the transformers too. They tend to shear on their mountings, although these do look okay. So if we're very lucky here, we can pull the chassis and put some new output tubes in, and it may just all spring to life. But jury out at the moment, and I want to hear from the client, so I'll report back to you when I've heard from him. Well, I thought whilst I was waiting to hear from the client I'd pull the chassis and have a little look. Here we are top side. As you can see, a couple of casualties here, another one here. This one isn't actually broken, and I would change that one anyway. Preamp valves look okay. Again, no obvious sign of trauma. The transformers are good, so they haven't sheared or moved. You can imagine it's a huge weight, this, and if an amp is dropped with a lateral force like that, these actually shear and even bend and buckle the chassis. I've seen many of those. Okay, so I think I'll flip it upside down. I don't expect to see much underneath, but we'll have a little look and see if there's any obvious damage there. Here we are on the underside, and it all looks nice and clean actually. Looks in very good condition. I can't see any obvious damage here. So I have no idea what's gone on with this amp. It wouldn't surprise me if the HT fuse hadn't gone. I'll check that. When a valve loses its vacuum like that, it can draw a largish current and take out the HT fuse. I'm feeling a bit optimistic on this amp. We might just get away with it. See, it's interesting, even the effects board here hasn't bounced out of its socket. Of course, it could have all been dropped down that way. So I think I'm going to check the fuses now, and then I will, I think, pop in a new quad of valves and bring it up a bit gingerly on the variac and see if we can get this thing working. Okay, let's have a little look at these fuses. I've got the meter set on beep. for short circuit, and we can just go down the fuses. That one's okay. That one's okay. That one's okay. I think this is the HT fuse here. Oh, surprise, surprise, that one is open circuit. So let's just take it out and have a little look. It is, I'm going to have to get my eyeglass out for this. 250 volts. Yes, standard HT fuse T 1 amp, so a time delay 1 amp fuse. Right, I'll just go and get one and pop a new one in. Okay, there we go, a nice T 1 amp fuse. We'll pop that in there. That's all ready to go. And I don't know if you heard my phone beep just a moment ago, but that actually was the customer saying go ahead with the new power valves and go ahead with everything basically. So we can now flip the amp over, and I'll put a new set of power valves in. I'll leave the preamp for the moment, see if the thing comes to life, and we can take it from there. Here we are topside again. This amp had JJs in, EL84s, sorry, EL34s. Now I want to tell you something that I've learned relatively recently. I've had a few JJ valves go in Marshalls, and after doing a little bit of digging and researching, apparently word on the street is that the JJ EL34s can't quite take the high voltage that these Marshall 100 watt amps put out. I mean, most of the time they're okay, but sometimes they don't like it and they fail. So I'm going to put in a set of Marshall EL34s. Of course, they're not made by Marshall. I forget who they're made by. I think it might be one of the Russian companies. And these can take a little bit more voltage than the JJs. So there's just a little tip for you there. They're great valves, JJs. It's just that the Marshall 100 watts seem to be a little bit susceptible to these JJ EL34s. So I'm not going to take any chances. I'm going to pop in these Marshall ones, which I happen to have a quad of, so that's very useful. Right, so let's see if we can get these valves out. Of course, a little bit tricky now that they've all come apart, and there's broken glass here too, so I want to be a little bit careful. You can see that's nicely broken with razor sharp glass all around the bottom. Same with this one, just being very, very careful. I'm pushing down on the spring as I'm waggling in a sort of circular motion, and that one's come out quite nicely too. This one seems to be not broken, in other words not cracked around the base, but I'm still going to be a bit careful. It's lost its vacuum, so it will definitely have a crack, and you won't be able to see this, but I can. I'm going to put my finger on just above my fingernail to the top of the screen as you're looking. There's a tiny hairline crack, and that's what to look out for when you have a valve which has lost its vacuum. My phone's going crazy. And this fourth one is probably okay. I'm just going to put that to one side. Okay, there we go. So I think we may as well just pop in the new Marshalls. I won't run the camera whilst I'm unboxing those, so just to save a bit of time I'll turn it off and come back in a moment. Right, we're ready to put in the new quad of Marshalls, and I remember now that these are made by Electro Harmonics. So that's that. And I've also put a couple of bias probes in whilst I'm at it, because I want to see what's going on with the bias on these. So we'll pop the new tubes in. The way to put a new tube in, it's got this key, of course, I'm sure you know, the sort of keyway, and just with a very delicate hand you just kind of rotate the valve very, very delicately, and it just drops in. The keyway just drops into the slot like that, and then of course you just push it push it home. So you don't need to kind of go crazy about looking at the keyway and trying to match it up. Just these things are a bit of a pest actually, these valve retainers. They're ever so hard to push down with your fingers. So sometimes it requires all my strength to do that, and I end up getting kind of not cuts in my fingers, but certainly big dents. Having said that about rotating, it is quite difficult to do the rotating trick with these springs. So you do have to match them to a certain extent. Right, there we go. So it's 4. That's quite tight, that. 4 valves in there, 2 bias meters. I think I'm just going to take the plunge and go ahead and switch it on and see what happens. How loud a bang can it make? I'll put in a speaker, 8 ohm speaker, and some power. There we go. And what's the status? Okay, it's on, but not in standby. I mean, sorry, in standby, not turned on. So you can see the plate voltage is quite high, you see, on these Marshalls. That's nearly 500 volts. That is 500 volts. That is a very, very high voltage. A lot of amps are like 450, and that makes a big difference. When the valves go, they flash over, and that really destroys them. That's not what's happened to these though. What's happened to these is this has had a big bang somehow. By the way, I spoke to the client and he doesn't remember the amp being dropped, so I've no idea what's happened here. We'll never know. Right, let's take it out of standby, see what happens. Oh, that's very promising. Good, bit high there. The amp's grumbling away a bit. I'm going to plug a guitar in and see if we get any amplifier type noises out of this amplifier. Now, where's the plug? Okay. Whee! Well. We have an amplifier working, so the customer got a bit lucky there. Just the power valves. And obviously I haven't been through the amp doing everything, but pots are all very scratchy, so they're going to need doing. And that's crunch mode. It's hard to do this upside down. Okay, well, I'm pretty happy with that. The next thing I think will be to bias the amp and get these into a more sensible range. See, the HT's come down a bit now because obviously the valves are drawing current and that's dragging the HT down. But when you first turn on, you can have a very high voltage, 500 volts. So I want to get these back into line. I'm guessing it's going to be about 40 milliamps. I'll look it up. And then we will bias the amp. Since this is a fairly short video, I'll quickly show you how to do that, and we can then take it from there, see what else needs doing. But it's looking promising. Okay, all I've done is flip the amp over, and I've got it supported on a couple of stands. I hope you can see the bias meters here, and it's like it was when we had it up the other way. In interest of accuracy, I'm not 100% sure those Marshall valves are electroharmonics, so sorry about that. I just can't remember, and I'm not going to look it up now. Okay, on this amp, we've got 2 handy bias pots here and here. So Marshall have made this very nice and easy for us. So let's start with the left-hand pot, which seems to do this one. The correct bias current for a 450 volt plate is 39 milliamps, so we're not going to sweat a milliamp or two. 37, 38, that's perfectly okay. And now the other pot. There's usually a little bit of interaction between the pots, not much. Anti-clockwise seems to reduce the bias current. Clockwise seems to increase it. Let's touch more on that right hand one. There we are, I'm happy with that. 37, 38 milliamps, 450, 460 volt plate, that's perfectly okay. Good, we're good to go. I'm going to wrap the video up there because there's nothing more for you to see that's very interesting. I'll clean the pots and check that everything is working on this amp, and then we can hopefully give the customer the good news that it only cost him a quad of EL34s plus some of my time at £500 an hour. Good. Well, there you go, that was fairly straightforward, wasn't it? Just replacing a quad of EL34s. I've been thinking a little bit about this overnight, and the EL34 JJ is fairly good for lots of amps, but not great on these Marshall 100 watts. They did produce an EL34-2 with a higher spec, and they are pretty good for these EL34 based 100 watt Marshalls, and you can also use the Marshall brand valves, which are also quite inexpensive, so there you go. But I wouldn't recommend using standard JJ EL34s on 100 watt Marshalls. For everything else they're absolutely perfect. Now, I've been having a little bit of a think about this overnight. The customer said that the amp definitely hadn't been dropped, not that he could remember anyway. Also, there's no sign of it being dropped, it's not bashed on any of the corners, the transformers are all tight. So I've just been having a little think about that, and I'm wondering if 3 out of 4 of these JJ standard tubes have failed in this amp. I have had amps back quite frequently with a single EL34 which has lost its vacuum in a 100 watt Marshall, and I sometimes put that down to it being knocked, but you know, I'm not so sure now. I think these JJ are failing in these 100 watt amps, and eventually, I don't know whether they get too hot, crack the glass, and the valve loses its vacuum. But anyway, the take home is don't use standard JJ in these, use the EL34-2 from JJ or the Marshall, as I said. Okay, well, I hope you enjoyed that. The amp came up quite nicely, I cleaned the controls, all's fine with it. I can now get this back to the customer and move on to the next amp. So thanks very much for watching, and I'll catch you on the next video.